Very good evening. Very good evening. How are you, Sankar?
Fine, sir. Natish. Elder, I came first.
Carry paper.
I came first.
Okay. Good evening, sir.
Very good evening. Nitish, how are you?
Good evening,
Yes,
sir.
sir, I'm fine, sir.
Very good evening. Congo, how are you?
Yes, sir, I'm fine, sir.
Okay. So, do you remember what we had discussed in the previous class?
Sir, we are doing bond.
Exactly. So, I think ionic bond we had discussed it in detail, right?
Yes, sir. We started covalent bond. No, we yes, sir. We started ionic.
That, yeah, first.
We started covalent bond.
So let's first see the various properties of ionic compounds, because all those compounds which contain ionic bond, they are known as ionic compounds. So what are the properties of these ionic compounds, right? So can you tell me, will these ionic compounds be soluble in water or not?
They are not soluble.
They are soluble, highly soluble, because these are polar, highly polar. So they are soluble in water. So let me write here that properties of ionic compounds, that is, they are highly soluble in water. So they are highly soluble in water, because actually see, water is a polar solvent, and these ionic compounds, they are also polar. For example, if I will show it like this, let's say NaCl, this is an ionic compound, right? That is sodium chloride.
Yes, sir.
And we can just write it like this, that this is polar. It is actually Na positive and Cl negative. We have already seen it, right?
Yes, sir.
Yes, sir.
Exactly, there is ionic bond between these two positively charged ion. So when you just put it in water, so a water molecule, it has also the polar nature. It is also the polar solvent. This is very important to be noted down, that water is a polar solvent, because oxygen is actually more electronegative. Electronegative means that it actually attracts these two electrons, bonded electrons, towards itself. So what happens because of that? Because of this, there is some slight negative charge on this oxygen, represented by del negative, and there is some slight positive charge on this hydrogen, that's represented by del positive. So
Yes,
this water is also your polar solvent, and this ionic compound, it's also
Sir, what is a polar solvent, sir?
polar means which has two poles. Poles here actually means the charges, negative and positive charge.
Polarity.
Okay, sir.
Polarity, exactly. It is actually polar here means which has
Sir,
two
so it will
poles.
become HCl and NaO.
Exactly. See, now what happens? This oxygen, it is negative, so that is why any positive ions, they will just get attracted towards this
Sir,
oxygen
so
because
it's
of this.
a double decomposition reaction.
Actually, a double
You have
decay.
not actually do any kind of reaction here. It is just the solubility. They just dissolve in it. There is no any chemical reaction taking place. Just there is a little bit attraction between these poles. So now this any positive and Cl negative, it is also your polar. So you have to remember that there is a rule, universal law is there, that is polar dissolves in polar. So this is polar solute, NaCl is your polar solute, and this water is your polar solvent. So that is why polar will dissolve in polar. This is very important to be noted down, that polar dissolves in polar because like dissolves in like, right? I hope you have heard this, like dissolves like.
Yes, sir. And unlike dissolve, see, sir, but alike and unlike only dissolves, right, sir?
Yeah, unlike and unlike, they will also dissolve. So polar dissolves in polar.
And what doesn't dissolve, sir? Like and like doesn't dissolve, sir?
Yeah, if there is polar solute and there is non-polar solvent, then that will not dissolve.
Oh,
Oh,
So
okay.
polar
yes, sir.
dissolves in polar, and if I will just write, okay, I will write it here that if I'm having, let's say, polar solute, so polar solute will not dissolve in, will not dissolve
Non-polar
in,
solvent.
exactly, will not dissolve in
Non-polar
non-polar
solvent.
solvent.
Sir, can you give an example of non-polar solvent?
Exactly, sure. For example, if I'm just writing here, see, water is your polar, right? Okay, first let me give the example of polar solvents. So I have told you that water is a polar solvent, but we are also having other solvents which are also polar. So for example, first you will write water is your polar solvent, then you will write the alcohol is also your polar solvent, etc. And similarly, you can also remember the example of non-polar solvents, examples of non-polar solvents. So the example of non-polar solvent is benzene. Benzene is your non-polar solvent. Similarly, carbon disulfide.
Sir, why
It is
are they not polar solvents?
They do not
because
have
there
a.
because there is no any charges separation. For example, if you will
Can
write
you give
benzene,
us few example of polar solute and non-polar solutes?
sure, exactly. Why not? First, let me tell you that benzene, its formula is C6H6.
Yes,
Can
sir.
anybody tell me, can we write benzene like C positive H negative here? No, this is a
No,
covalent
sir.
compound. We cannot.
No, sir.
So that means there isn't any charge separation. There isn't any positive negative charge. So that's why it's your non-polar solvent. Got it?
Yes, sir.
Oh,
Yes, sir.
yes,
Yeah,
sir.
this is very important. So similarly, we can have carbon tetrachloride.
Sir,
That is all.
so because carbon is negative and hydrogen is positive and they already combined and they neutralize, that's why we can't write a charge.
Yeah, there isn't any actually cation anion here. There is a covalent bond. Covalent bond means there is
Yes, sir.
mutual sharing
Yes,
of electrons. Yeah.
Yes.
So carbon tetrachloride, it is also example of non-polar solvent. Okay, now
sir. Can you hear us, sir?
yeah. Can you hear
Oh,
me?
yes, yes.
Yes,
We
sir.
can hear you. Now we can.
Okay. So let me give examples, more examples of your let's say polar solute. For example, NaCl, it's your polar solute, right?
Yes, sir.
So let's see
Potassium
another.
oxide.
Yeah, potassium chloride. It's also your
Potassium chloride.
polar
Sorry.
solute. Potassium nitrate. Similarly, potassium sulfate. They are all your polar.
Hydrochloric acid.
That's
Yeah,
all. I'm
exactly.
pretty sure.
That is actually hydrochloric
But
acid. It is acting as a solvent. It is also polar, right?
yeah, I said no. Sorry.
Sulfuric acid. It is also your polar. So all these are polars, right?
Yes, sir.
They are polar. So have you noted down this? Shall I move to the next
1
page?
second, sir. I'm in the last.
Yes, sure.
Sure.
Yes, sir. Sir, so even like methane, ethane, sorry, methanol, ethanol, propanol, and all are
They are
non-polar.
all non-polar
No,
solvents.
I told it is polar. Alcohol is polar. Whether it is methanol, whether it is ethanol, they are polar. For example, if I write
Oh,
that is CH3,
So your
CH2.
screen
sir,
share
Sir,
is
you
not
the
visible.
stop your
share
screen.
screen is off.
What is the problem? Why it stops automatically?
So this slide, I took a print screen. So,
Everything that you told today in school
What
also.
have you written?
oh, only for maths.
Said again when, sir.
Bring your chemistry book tomorrow. I'll bring mine also.
So is it now visible?
I won't be coming to
Yes,
school
sir.
tomorrow. Sorry.
I don't absent tomorrow.
So this is your ethanol. Ethanol is also your what? It is a alcohol,
It
so
is
it is a polar.
polar solvent.
Exactly, it is a polar solvent.
Sir, but like you can't separate it, right?
It's an
Okay, okay.
It's
It is just
universally.
Oh, the OH is there, right?
yeah, there is oxygen. Oxygen is more electronegative. There will be slight negative charge on the oxygen and slight positive on the hydrogen, as just in case of water.
Sir, but
Are
Sir,
those
what about
methane
methane,
is
sir?
Sir,
the
are those
methane,
dashes
Methane only.
comma?
C2H6.
Excuse me, sir.
Yes, sir.
Mhm.
Sir, are those dashes commas or are those bonds, sir?
They are
Dashes,
bonds. They
the
are
bond.
not comma. They are bonds. These are
Okay.
bonds.
Okay.
So what about methane, ethane, propane? They don't have
Sir,
oxygen
Yeah,
molecule.
yeah.
butane.
They are non-polar. Methane, ethane,
Oh, they
propane. They
are
are
hydrocarbon.
Oh,
Carbon. They're all
exactly. They are
alcohol.
hydrocarbons. They are also your non-polar solvents.
the
Yes, they're
non-polar.
all alcohols. Okay, yeah, I
What?
get it.
Ethane, methane. Oh, okay, there.
They're hydrocarbons.
Methane,
Yeah,
ethane,
yeah, yeah.
propane, butane.
They're
So
not
have you noticed
alcohol.
this?
Yes, sir.
Yes,
Yes,
sir.
sir. Everyone finished, sir.
So the first property which we studied here, that is ionic compounds. They are highly soluble in water because these ionic compounds they are polar and water is also polar. So definitely they will be soluble
So
in water, right?
non-polar solvents, I mean non-polar solutes do not like
Sir, what
dissolve
will
in
happen
water.
when a non-polar solute reacts with a non-polar solvent, sir?
That will also
It'll
dissolve.
dissolve.
Because
Will
light
also
dissolves
dissolve.
in light. So when we are having non-polar solute, it will also dissolve in non-polar solvent.
Opposite of a magnet. They are no a magnet. Yeah, opposite sides only attract. In this,
See now.
only like sides attract. Not
So let's
attract.
see the
Combine.
second property. Now, can you tell me, are these ionic compounds liquids or gases or solids?
The liquids.
No, ionic compounds are always solids.
Uh, are they crystalline, sir?
Exactly, they are crystalline solids. So ionic
Oh.
compounds exist as solids. Most of them are crystalline, but few may also be amorphous. But you have to remember that they are solids. For example, if you just talk of sodium chloride, what is this? It is exists in solid state, right? Potassium
sir.
chloride, they are
Sir,
it's also a
crystal.
solid. Yes, we are having potassium sulfate, it is also your solid. So
So
that means
HCl is a covalent compound, right?
yes, exactly. There is covalent bond in HCl, but that
Sir,
is
is
polar also.
NaCl an efflorescent substance?
NaCl,
That has
yeah.
nothing to do with this.
Okay. No, I just asked. I heard.
Okay. So
Yeah, that's how
then
you learned.
next property. So can these ionic compounds conduct electricity or not? Will they be
Sir,
good
they
conductors?
have.
Yes,
I
sir.
mean, they have a
Yes,
charge.
sir.
Because they
can-
have a metal in them.
They have a metal charge.
They have metal in them, so
They have
they
a
will
charge.
conduct electricity, but in which state? That is very important.
Sir,
Solid
in the
state.
electric state.
No, 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 no. In
Solid
solid
state.
state, they are bad conductors.
Solid. Sir, how can electricity be solid, sir?
No, da. Not the
Ionic
state of electricity.
Oh, the
the state of
conductor.
the the conductor.
State of that
Ionic compounds are bad
Compound.
conductors. Here, ionic compounds are bad conductors in solid state, but good conductors in liquid and molten state, aqueous and molten state. That is to be remembered. That's very important. So, but they are good conductors.
So you said they're bad conductor. Oh, okay.
Yeah,
Bad
solid
conductor in liquid state. Okay.
but good conductors in molten and aqueous state. That's very important to be
Molten in
noted.
the sense like iron when it's molten state, like that, sir?
No. Sir,
No, NaCl and
Oh, it's a
I will tell you.
compound. Okay,
I will tell you. I will tell you.
I forgot about
Molten
between
means,
your
for
house and your
example,
neighbor's house.
see, this is your NaCl. It is your solid, right? So no
Yes, sir.
ion is
Turn on
free
your video.
here. So this is solid. Now if you just heat it, it will melt, right?
Yes, sir. Then it's a good conductor. It will become
Yeah,
a good
when it will melt, it
Yes,
will
sir.
just get converted to liquid. So this is the molten state. So when it is in molten state, the ions will get free. That means now you are having any positive ion, Cl negative ion. So free ions can easily conduct electricity. But when it was just closed, when it was just solid, then the ions, they were tightly held with each other. Ions were not free. So that's why it's bad conductor in solid state. But when you just heat it, it just melts. Ions get free ions are here, so free ions can easily conduct electricity. This is very important. And what is
Sir, can
aqueous
you
state?
say that again? I didn't get
where
it.
water is a solvent, sir.
Sir, can you
Exactly.
say that again?
Okay, I will repeat it. See, I just told, for example, if you are having just this is your crystal of NaCl. Let's say this is one of the piece of NaCl, right?
Yes, sir.
Sir.
It is the solid, right? Solid means here Na and Cl, they are just tightly held with each other. But when you just melt it, what will happen?
Sir, it will become a liquid.
Exactly. When it will become liquid, that means ions will be free. You will be having any positive ion, you will be having Cl negative ion. They are free now.
So
They
like
are free
choose
to
the
move.
path. So choose the path with
Sir,
ions.
so they are not fused together.
They're not, no,
Exactly. In molten state, they are free. They can just
they
conduct
are
electricity
fused in a
because
solid state.
electricity is
So
only.
they'll ignore all the chlorine ions, and they'll go through the sodium ions, right?
No, you have to remember that conductivity, it is because of both any positive ion and because of Cl negative ion. You
From
have to remember.
positive to
How is
negative.
it
Oh, so
possible by
chlorine is also a
Na?
conductor.
Yeah, yeah,
Yeah, both they have negative. They
exactly.
have
Cl.
charge. As long as they have charge.
So
As
like
there are free
Say
ions,
Congo,
when there are free.
NaCl together does not have a charge. That's why.
Yes, when it is in
explain
the
my doubt.
solid state, it is neutral at that time, right? But when you just heat it, when it melts, the ions, they get free. When we have free ions, they can easily conduct the
Sir,
electricity,
so
whether it is your
if I
fault.
keep
Hmm.
if I keep two wires and keep chlorine in the middle, will they form
Yeah,
a
it will
closed
work.
circuit?
It will work. I think.
Will okay, I will tell you. For example, let's say this is your one of the wire.
Wire.
It
Wire.
Then I
okay.
keep
Then
one
I have
chlorine
just
tablet in the middle.
I have just here a solution of NaCl. That is aqueous solution of NaCl, right?
No,
Let's say
only chlorine, sir. Only chlorine.
okay. Exactly,
Only.
that will also conduct electricity. Okay, let me write here
Oh,
that if there only chloride ion, but it should be ion, not the atom, neutral atom. It should be just a Cl negative ion. So if we are having Cl negative ions here,
where
they
can I
will.
get that from, sir?
You can get from this NaCl.
Sir, you have to separate the NaCl liquid, sir. Like
You have to separate these ions with the help of electrophoresis. If you cannot separate,
electrolysis,
you
sir.
can still take. Yeah, you can
No,
still
sir. I'm
take.
asking like raw chlorine, like raw
No, no. If
sodium can conduct, right? Like that can raw chlorine
no.
conduct.
If you are having the sodium chloride in the solid state, that means it is completely packed. So that will be bad conductor. That will not conduct electricity. Ionic compounds are bad conductors in solid state. I have written down here, but they are good conductors in only molten state when you melt, and when you have aqueous state, that means in water. At that time, it will just conduct. Got it?
Okay, like chlorine alone without which never has been in an NaCl solution can be found in a rock form. Like we are talking about
Like I go to the
Cl.
shop, buy chlorine, and I keep that.
Yeah, you can buy chlorine
Will it
alone on
work, sir?
something, but we are talking about chlorine from NaCl, not chlorine chumma getting it somewhere.
I
Yeah.
am
Okay.
talking about that chlorine.
Yeah,
I
Hey,
we are
got
he's
you.
talking about that
Sir,
chlorine.
hey,
Like,
I
chlorine
know what
from
you're telling.
NaCl only you're talking.
Hey,
I
Nitish
got.
is telling that when we
So if you
separate
are
that chlorine from NaCl liquid and we take it, is
Hey,
that to
forget
conduct?
NaCl.
Forget
Forget
NaCl means it will
NaCl.
work. It will work. Forget
okay,
NaCl means it will work.
Yeah,
see here. If you are just going to the market and you are just taking the chlorine tablet, chlorine, it is their Cl2. It is your covalent compound. It is not the ionic. At that time, it will not conduct the electricity because it is bad conductor. Covalent compounds are bad conductors of electricity. It is a
Oh, you
Cl2.
can't get individual ions.
you
Yeah,
can't get
exactly. You
CL.
cannot get.
Individual
No charge.
ions.
Okay.
Exactly. This is very important point to be noted that you cannot get the individual ion. Exactly.
So you can get it only through NaCl compound.
Exactly, exactly. Whenever you
Also,
have
there's no.
at that time you can get these ions, and that's why in the molten and aqueous state they are good conductors. Got it?
Yes, sir.
Screen visible?
It's visible, but
Yes,
it's
a gray
horizontal.
screen,
I
sir.
mean, yeah, it's a horizontal, vertical, and blank. Now it's
Yeah, now
horizontal
it's
and
there, sir.
fully.
Okay.
But I don't
So
want.
shall I move to the next page?
Yes,
Yes,
sir.
sir.
So tell me
Yes,
the
sir.
next property. Next property is that these ionic compounds, they undergo very fast reactions. That's they undergo ionic reactions. So ionic reactions are very fast.
Very fast in
Ionic
the sense like how? So I don't understand fast.
reactions are very fast. Fast means they just
They're
take
highly
within minutes.
reactive.
Yeah,
Highly
highly
reactive.
reactive.
For
Oh,
example,
highly
if
reactive.
if
What's
if
fast?
you're just having NaCl, right? This is ionic compound, and you are just taking AgNO3, that is silver nitrate. Both you are taking their aqueous solution. Aqueous means in water. So that means you are just having these ions. So there will be ionic reaction. So this reaction is very fast. It just takes place within seconds, and you will get NaNO3, silver chloride and NaNO3, right?
So it's
It's a
like I have
precipitation
NaCl. Suddenly I
reaction.
put and then suddenly I get AgCl and NaNO3.
Exactly, exactly. For example, if you
Oh,
are having aqueous solution
oh,
of
in an
any,
aqueous state. Okay, in an
yeah, yeah.
aqueous.
If you are just having in aqueous solution NaCl in one beaker, and in another beaker you are having the AgNO3, and when you just mix them, you will just get these. As soon as you mix, you will get the product. So that's why I told that these reactions are very fast. Right?
Yes.
So
Yes, sir.
Yeah. So we discussed it that these covalent compounds, they usually exist in the solid state. They are bad conductors in the solid state, but good conductors in the molten and aqueous state. And they undergo ionic reactions, which are very fast. Next, I told that these ionic compounds, they are highly soluble in water, right?
water. That's
Okay, tell me what will be their melting and boiling point? Will it be high or low?
high.
It'll be so low, sir.
It will be so low because it's soluble in water.
No, no, it will be very high because ionic bond is a
L
strong
because
bond.
L.
Also,
Ionic compounds
Hey, all of
have
us guessed it, okay?
Hey, I guess it.
ionic
It's
compounds
okay. I
have
you
guess it
guessed
right.
it right.
I
We
guess
all
it.
guessed
Not
it.
I guess it right. No, that's all this matters.
very high melting point
We
and
still
boiling
guessed
point.
it.
That's,
So they have high melting point and boiling point, both. So can you tell me what is melting point?
it's a
It
point
is
where
the
It's the
point
temperature
where
at
the
which any substance turns
where
into
the L
liquid
goes to
state from the
liquid state.
solid state due to heat.
Exactly, exactly.
Yeah,
So
due
whenever
to
you have to remember what is melting point, you have to remember that it is not the point, it is just the temperature. It is the temperature at which solid gets
Sankar
converted
used
to
the
liquid.
wrong word.
L goes
And
to
similarly, boiling point is also the temperature at which liquid gets converted to gas, right?
heat.
Liquid to vapors or gas. Similarly, melting point means when solid gets converted to liquid, right? It is the
Yes,
temperature.
sir.
Okay, so ionic, you have to remember that ionic bond, it is stronger bond as compared to the covalent bond. So ionic bond, it is stronger than covalent bond. Covalent bond is weaker than ionic bond. Got it?
Just pull it up.
So this is the bond strength. So that means which bond has more strength?
Ionic bond.
Exactly, the ionic bond.
So this covalent bond will quickly break.
As compared to the ionic bond, not so much quickly, but as compared to the ionic bond, it is weak.
Like
You have to
me.
compare both. So have you noted down this?
Yes, sir.
Yes, sir.
So then let's move towards the covalent. Ionic bond we have discussed it completely. So let's see now the covalent bond.
So
In the
So
opposite of
textbook,
covalent bond.
nowhere they gave ionic and covalent bonds, sir.
What?
A textbook, when I was just going through it today, they didn't give ionic
there
or
it should be there. If it is not written ionic, it should be there electrovalent, because
yeah,
electrovalent
yes, sir. Electrovalent.
If you learned yesterday,
elect-
one know that.
I told you that ionic bond is also known as electrovalent bond.
Sir. They
It is
wrote
al-
electrovalent.
What
it
is
is already
garbage?
it is already in your syllabus, so I am going through that. So covalent bond, we have already discussed that it is formed by mutual sharing of electrons, right?
Yes, sir.
Formed by mutual sharing of electrons. So I have also told you that and this covalent bond, it will be formed between two non-metals, right?
Yes, sir. It's a mutual
Yes, sir.
sharing between two metals of electrons between two metal.
Between two non-metals. Just if you are having H2 molecule, both hydrogen atoms are non-metal, so they have just shared
So they are
one electron. So they have completed their duplet, right? I hope you remember we elements complete
Yes, sir.
duplet.
Duplet
yes,
rule
sir.
and octet rule.
Duplet rule
When
and
the
octet rule,
two
sir.
electrons in valence shell.
Valence shell.
That is followed by
Sagwan.
hydrogen,
Followed by
helium.
Hydrogen, helium,
hydrogen, helium, lithium, beryllium.
beryllium.
Exactly. So this HF molecule, it's also your example of covalent bond because fluorine just gives one electron and it mutually shares it with the hydrogen, one
But
electron. So octet
how
of
does
fluorine.
it work with helium, sir? Helium is a non-reactive
Exactly.
element,
Helium
right?
is a noble gas. Helium is noble gas.
Yes, sir, but how can it share electrons when it doesn't need anything to share?
I didn't told that helium will share any electron. It is a noble gas, so it is less reactive.
So it even
Actually,
says
see,
See,
about
you don't
helium,
need,
helium.
it already has two electrons in its
it
valence shell.
already has two electrons. It is duplet is already complete.
It's
Why
already
it will?
stable.
Yeah, it's already stable. It is a noble gas, hence
Goes for
stable.
the-
Sir,
Already.
and even
Duplet
say the
rule
word
is, sir,
helium.
but duplet rule is when like a reaction takes place, and that's when the two
Duplet rule,
No,
it
no,
has
no,
to
no.
have two electrons.
No,
That's
no, no,
enough.
no. I haven't written that
Sir, you wrote two
duplet is to
electrons
be
in valence
completed
shell,
on.
sir.
I have just written that duplet means having two electrons in the valence shell. There should be two electrons in the valence shell. That means duplet is complete.
so it doesn't matter if it is reactive or non-reactive.
Exactly. For example, neon, atomic number 10. So that means what is the electronic content? 2,
Sir,
8. So its
2 and
octet is
2, 8. It's already formed
exactly.
the
Its octet is already complete. So that means it is following the octet rule.
octet.
It will not react. It will not react because its octet is already complete. Got it?
Yes, sir.
Exactly. Okay, now you have to remember that covalent bond, it can be single, it can be double, it can be triple. Exactly. Yeah. We had discussed the examples, correct?
Yes, sir. Fluorine,
So
oxygen, and nitrogen.
exactly. In case of, for example, F2
Fluorine.
molecule, it will be their single covalent bond. In case of O2 molecule, there is double.
And then nitrogen.
In case of nitrogen, there is triple covalent bond, and I have already discussed this in the previous class, right?
Yes, sir.
Sir.
Can you tell me how many lone pair will be on the oxygen in case of O2 molecule?
One
four.
lone pair, sir.
4 lone pairs.
Yeah, in total there are 4 lone pairs, right?
Okay, in total.
Total
Okay.
4 lone pairs.
Yeah, you have sometimes question is asked that in F2 molecule, how many lone pairs will be there? So can you tell me how many lone pairs?
2.
F2 was 12. Well,
6 lone pairs.
sir, F2
Two.
was
See, in
F2.
on each fluorine there are 3 lone pairs. 1, 2, 3. So 4, 5, 6. Total 6
sir,
lone pair, right?
each 2 are like 1, sir.
It is lone pair. Pair means 2,
Oh,
right?
I didn't think of that.
It's lone pair. Okay, now tell me on O2 in case of O2 molecule, how many lone pairs are there?
4 lone pairs.
4 lone pairs.
2 lone
Okay,
pairs
in
for
case of
Two.
in case exactly. So this is their lone pair. Now can you tell me the bond pair? This is also important.
What is bond
No,
pair,
sir.
sir?
Bond pair means
sir,
that
it is
bond
Which
pair
is-
is two,
One.
sir. Two.
one
Pair. It's a pair. There's
bond
two
pair
is one.
is the pair. So pair means one.
Here also 2. Here 2. 2 bond,
Yeah,
bond
here-
pairs.
Here
And next
3.
3 bond pairs.
Bond pairs will be here 3. Got it?
Yes, sir.
Yes.
Okay, I will again write it. For example, if I just take the water molecule, I can write like this. Water has band shape.
104 degree 5 minutes.
Exactly. There is the angle 104 degree and 5 minutes. Very good. So can you tell me, so this shape is known as band shape.
Pen shape.
It's also known as V shape, capital letter V.
Yes,
Can you
sir.
tell me in this water molecule, how many bond pairs and how many lone
Two.
pairs are there?
2 lone pairs and 2 bond pairs.
Exactly. There are 2 lone pairs. So there
And 2
are
bond
also
pairs.
the 2 bond pairs. Correct. 2 bond pairs. One is this one.
The other one is the That's it.
This one. Got it?
Yes, sir. So what if like something like H2O2 in the sense, will we have to
But
count every single bond pair, sir? H2O2 in the sense.
exactly. For example, if it is H2O2 hydrogen peroxide, first you have to make it Lewis dot structure. So how to make this structure? Structure is like this. Then you have to tell how many lone pairs are on the
So, but
oxygen. Can
won't
anybody tell?
oxygen form a double covalent bond, sir? Don't
In
they share
oxygen,
two
there are
pairs?
in
Two
oxygen
bond
there
pairs?
are two lone pairs.
No, two bond pairs. Oxygen.
Uh,
Two bond
See
pairs.
now here. See, can you tell me again what is the valency of oxygen?
So, two.
uh,
Very good. Oxygen valency is 2. That means it
two.
will
Two
form
negative
two
less,
bonds.
two
It will form
already.
two
Oh,
bonds.
it's already
Two
found
bonds.
a duplet rule. Okay.
Are you getting that oxygen? Its valency is 2, so it will form two bonds. So in
So the
case of O2
valence,
molecule, it has formed the double bond. So that means it has
so
formed the
if
two
the
bonds.
number
But
of
here
the
O2,
valency
there
number
is
is
one bond
basically
here,
the bond number.
another is here. So that means it has also formed the two bonds.
Oh my God.
Got it?
Okay. Sir.
The valency
So if
number
it's
is
oxygen,
basically the bond number, sir.
no,
Yeah.
I don't know.
So
The
what if
bond
last
That's
See,
not valency. Is not the bond numbers, yeah.
so what if
Lone pair number.
last
No, it's not.
It is.
The number of
What
is the
electrons
combining
that
capacity of
can
an
replace
element.
a hydrogen atom. That's not the same thing.
Valency simply means the combining capacity of an element.
It's the
Combine.
ability for it to element to combine or displace an electron to combine or displace another element of an atom.
Exactly. You can define it, and there are a number of ways to define valency. One of the way is that it is the number of hydrogen atoms or double the number of oxygen atoms.
Or
And
element.
it is also defined as that
Number
is
of
the number of
electrons
electrons
Electron
lost.
atoms that
donated.
can combine or displace.
Exactly. It is the number of electrons lost, gained, or shared. You
Or
can also,
what is this? Halogens also.
exactly, a number of halogen atoms. Correct. So now tell me here in this H2O2, can you tell me the number of lone pairs and number of bond pairs? This is very important.
So at one
H2O2.
lone pair, see, three lone pairs and two bond pairs.
How many lone pair will be there?
Three.
Sir, in hydro,
Three
sir,
lone
like
pairs.
I don't get your question. Like
Question is that in H2O2 molecule, how many lone pair are there and
Three
bond
lone
pair?
pairs, sir.
3 lone pairs.
Three lone pairs.
Lone pair
no,
will be
no,
4.
no, no.
Three
Sir,
lone.
lone pair is 4, sir.
How?
Okay, tell me how.
Say it
Because
after
How?
Sir, because like in
on
O2,
each oxygen,
sir,
there are 2 lone pairs. So total there are 4 lone pairs. Got it now?
Lone pairs. Yeah, I put bond pairs. Three bond pairs.
What's that?
Oh my God.
Can you repeat what you said
sir,
now?
bond pairs are 3, sir.
Three bond pairs.
Exactly. Exactly. Bond pair will be 3, but lone pairs are 4. Got it?
Yes, sir.
Yes, sir.
Yes.
Shall I move to the next page?
Yes, sir.
Yes, sir.
So
Sir,
then
one
if
second, sir. Can you just
okay, I'm going to the previous slide.
can you just tell how you found the lone pair and bond pair in that?
It's easy, right?
Have you got it? How to calculate the number of lone pair and bond pair?
Sir, can you just do it once more? I couldn't hear.
H2O2, sir.
Okay, sure. I will tell you. See, in case of H2O2, each oxygen and hydrogen atom, they have just shared one electron. So that means they have formed single covalent bond, right? Now, in case of oxygen, if you just tell me how many valence electrons are there. So can you tell me there are 6 valence electron, right?
Yes, sir.
Sir.
Okay, tell me among these valence electron, it has just shared one electron with the hydrogen, another electron with the oxygen. So now how many are left? Among 6, 2 electrons it has shared. So that means 4 are left. 4 means 2 lone pairs. Got it?
Yes, sir.
Yes, sir.
Same will be the case for another oxygen. So that means another oxygen atom that has also shared the 2 electrons with the one with the hydrogen with another oxygen. So these 6 electrons, 2 has been shared, and there will be 4 electrons will just act as lone pair electrons. Got it?
Yes, sir.
Sir,
Okay.
are there more number of ionic bonds or covalent bonds in this until we
More
discover
number
that?
will be the covalent bonds, because if you just see the organic compounds, I have already told that carbon forms billions of organic compounds. So they are all covalent bonds.
Like they
They are
all
all
only
covalent bonds.
non-metal and
Oh.
non-metals are combining, so it's
Yes.
a
Exactly,
covalent
exactly.
bond. There is no metal
Okay.
included, so it's not an ion.
Now, can you
So
tell me the
fluorine has 7 in the outside, right, sir? On the valence shell.
exactly?
Huh?
Yeah.
So if it shares 1, won't it
Mm-hmm.
be 12?
6.
Sorry,
So 3 lone
won't it
pairs.
be 12?
See, fluorine has 7 valence electrons, right? 2 comma 7. So if it just shares one electron, so it will complete its octet. If it just shares one electron with another, let's say hydrogen atom, so it will just complete its octet. Octet is now complete.
Yes, sir.
Hydrogen
Yes, sir.
triplet will also get complete. This is how it actually works.
Okay,
Got it?
so lone pair is in this
Exactly.
1.
Tell me
3
now total
pairs.
number of lone pair
3
here.
lone pairs.
1.
Exactly.
No, 3.
And bond pair?
Bond
Sir,
pairs 1.
Bond.
Sir,
Bond
is
pairs 1.
FH?
Bond
What
pair
is
is 1.
FH called, sir? FH.
Fluorine and hydrogen.
Yeah, what is
Not
it called?
H, it is actually HF, hydrofluoric acid. It's known as hydrofluoric acid. HF, hydrofluoric acid. Hydrofluoric acid.
Yes.
It is also known as hydrogen fluoride. You can also name it as hydrogen fluoride. Got it?
Yes,
Sir.
Yes.
Just what is the name for HCl? What is the name for HCl?
Hydrochloric
Hydrochloric
acid
acid.
or hydrogen chloride.
Hydrochloric acid.
Hyd-
Yeah,
Hydrochloric
exactly.
acid or
Hydrofluoric
hydrogen chloride.
acid or
Hydrogen chloride.
hydrogen chloride. Very good. You can call it by both the names. Now tell me that of methane. So how you can just draw the structure of this methane. So can you tell me how many valence electrons carbon has?
4. 4.
Exactly
Four.
4.
2, 4, 4.
4. Okay, if I will just write this is my carbon and these 4 dots are the 4 valence electrons. Now we are
And
having the 4 hydrogen atoms.
there is no lone pairs and there's 4
Oh,
bond
there,
pairs.
there are no lone pairs, but there are
Bond pairs.
Exactly.
4.
Alpha-
Wait.
Yeah,
Sir,
there's
there
4
are
bond
4
pairs.
bond. There are 4 bond pairs.
That's what I said.
You said no bond.
No,
pairs.
I said El Bozo. I said first.
So each hydrogen will
I
just
said
give
four.
one electron
Hey.
and there will be mutual sharing of electrons. So that means bond pair here will be 4, bond pair will be 4, lone pair is 0.
0.
There is a lone pair on the carbon.
Great.
Got it?
Yes.
Yes, sir.
This is very important. I hope that you can now tell me the number of lone pairs and bond pairs in any molecule, right?
Sorry, any molecule.
Any. Okay.
Okay. If I will just
top of
give,
that an asterisk, sir.
if I will just give the example CO2. So can you tell me the lone pair
There'll
and
be
bond
6
pair here?
things. 6 also.
Sir,
just calculate
Oh,
and-
I forgot.
Sir, 0 lone pairs. 0 lone pairs and 2 bond pairs, sir.
You have to tell me the lone pair in the whole CO2 molecule. How it can be 0?
See how
0
many
is not possible. I will tell
okay.
you.
So carbon has
So
4 and
carbon-
oxygen has 2.
Sir, wait, sir, don't do it,
Exactly.
sir.
There's 2 oxygen.
Okay. Just
So can
you
you draw
do
the structure?
yourself. You just first try yourself, then I will tell you.
Um, sir, I found out, sir.
Okay, tell me.
What is this? Carbon has 3 lone pairs, oxygen has 2 lone pairs, and there's 1 bond pair. Okay,
No.
for sure, I said 3 lone pairs and 1 bond pair. Oh, there's O2. O2. Okay, sir, nothing. 1 second.
Oxygen is 2 comma 6, so it has 6 valence
Okay.
electron, right?
Yes, I forgot about O2, so I didn't know there's 2 O2. I mean, 2.
First, try to draw the structure of this CO2 molecule. How will be the structure? Structure should be in such a way that octet of all the atoms should get completed.
Wow, lala. So I think there'll be 6 lone pairs and 2 bond pairs.
Lone pairs will be only 4. Okay, I will tell you.
1, 2, 3,
See,
4, 5,
carbon has how many valence electrons?
4.
4.
Four.
Sir, what
Exactly.
is this?
How many
That
mistakes
means, okay,
we
okay.
made?
4 lone pairs
I
and
know, right?
2 bond pairs. 4 lone pairs and 2 bond pairs. I got it. Fact.
Now see here, oxygen is there. Oxygen has 6 valence electron, right? Are you getting? Oxygen has 6 valence electrons, so it will just share two electrons,
Double
because in order to
covalent.
complete.
I took
Right.
carbon as like in
Four
the
lone
previous
pairs.
one, 4 dots like
The 4 lone
took-
pairs and
I took
2
carbon
bond
like
pairs.
in CH4, sir.
What you are, yeah, question that if you just took in the just as I have taken here in case of methane, but then how octet will get completed? You
No,
can check it out here that
Like,
I did that and I was like, what's happening?
So I got correct.
Yeah.
4.
So now
lone
you
pairs
can
and
check it
2
out
bond
here
pairs.
that octet of both the oxygen atoms is complete here, and also the octet of carbon is also
Carbon is
complete here, isn't it?
Yes, sir.
Yes, sir.
So
2
that
bond pairs.
means
and-
there are
Oh no.
total
4
lone pairs will be
4
4.
bond pairs.
Exactly, this is now correct.
Okay. Yes, sir.
Yes, sir.
So that you have to remember, if octet is not getting completed by single covalent bond, then you have to make the double covalent bond. Similarly, if octet is not getting completed by the double covalent bond, then you have to move towards the triple covalent, right?
Yes, sir.
Exactly. So shall I move to the next page?
Yes, sir.
1 second, sir. 1 second.
Yes, sir.
Yes, sir. You can go, sir.
Okay, if I just tell you that what will be the number of lone pairs and bond pairs in carbon monoxide and also its structure. So can you try it out?
Sir.
Yes, sir.
Okay, just try it. Octet both the atoms should get complete. This is the important point.
Yes, sir. Sir, it has 3 lone pairs.
Wait,
and
da,
2
wait,
bond
da.
pairs.
Be quiet, da.
Elbow.
Shut up.
Okay, just try on your notebook. Then
Your answer's wrong.
finally,
Let's go elbows up.
I already did it. It's correct. I'm pretty sure it's correct.
Nah, man, nah. 1 second, sir. Almost done.
okay,
Done, sir.
I finished first.
tell me.
So I finished first,
Okay,
sir.
tell me.
Sir, 3 lone pairs
3 lone pairs.
and 2 bond pairs.
That is wrong.
Sir, 2 lone pairs and 2
Sir,
bond pairs.
4 lone pairs and 2 bond pairs. Sorry, 1 bond pair, sir.
No, that's also wrong.
1 second.
Sir,
I
2
got
lone
one
pairs. Sir, is 2 lone pair correct?
2 lone pair is correct.
What?
Yes, sir. And then bond pair is also 2, right?
No. Bond pair will be 3. Let's see how.
Oh,
So carbon
I get it.
has 4 valence electron, right?
Yes, sir.
Yes, sir.
Is carbon having 4 valence electron?
Yes, sir.
Yes, sir.
Okay, then tell me how many valence electron are there in oxygen?
6.
6.
Exactly 6. And what we have to remember, that octet should get completed, right? Octet
Yes,
should get
sir.
completed.
Oh, okay. I get it.
Is screen visible?
Yes,
sir.
sir.
Yes, sir.
Okay. Let me draw it here. That first you are having the carbon and you are having the oxygen here. Carbon has how many valence electron? 4.
4.
So if I
Bond
just
pair should
4.
be 4, right, sir?
if I
No.
just write 2 electrons here and 2 here, and that is the 4. Now in case of oxygen, I am having total 6 valence electrons. So if I will just write 2 here
2, 2,
and
2.
2 here and 2 here, exactly 2, 2, 2. So then can you tell me, is octet of carbon complete here?
Sir.
No, sir. There's only 6. It's only
Yeah,
6, sir.
exactly.
Oh,
It has
yeah.
only 6.
4 of it should go.
So it has
So we
only
have to
6
draw all
valence electrons.
carbon in one side, sir.
So what you have to now
All
do,
4 carbon.
what you will do now here, this is very important. You'll just take these 2 lone pair electrons and you just make another bond here. So the next structure, actual structure, that will be like this. That is the carbon. There is here lone
But
pair. There are now
I found that lone pair just create a bond with other two
Sir, why
lone pairs.
are we doing this, sir? We formed the duplet rule, right? Giving the
No,
two
we
Sir, but
duplet
in
rule.
this
No, no,
diagram,
carbon
there's
doesn't.
five,
Carbon
sir.
doesn't form.
Sir, in this diagram, no, sir. In this diagram, carbon has 5 valence electrons. How, sir?
Yeah, I will tell you. Actually, oxygen is giving 2 electrons to this carbon. This is another special type of bond formed here that is known as coordinate or coordinate bond, or it's also known as D2. This is very important. Coordinate bond. So this is special type of bond.
How are we
Coordinate
supposed
bond.
to do this question if we didn't even know what coordinating bond was?
Yeah, I think it will not be in your syllabus, coordinate or D2 bond, but you have to remember that when one atom donates its electron pair and is then shared by both, this type of bond is known as coordinate or D2 bond. But this is only due to the reason that they actually are completing, both are completing their octet.
Yes.
Got it? This
So
is
that
very
means that
important.
two lone pairs gets converted to one bond pair.
Exactly. Two lone pair actually get converted to the bond pair in order to complete the octet atoms. Got it?
Oh my god, this is so.
This is very important.
So
I hope
who
you will remember
invented the
this
bond? I
example.
mean, not invented. Who discovered the bonds of electrons and electrons? Sir?
Okay, I will tell you. For example, if you just talk of ionic bond, it was discovered by Causal,
Oh, what?
Lewis and Causal. There were actually two, but credit goes to Causal, Lewis and Causal. It's the talk of 1916.
90.
And if you just talk of covalent bond was discovered by Langmuir.
So, but when did they find on when and who did find that electrons have a bond? So electrons create a bond with each other, like not the ionic or covalent.
Bond is what is bond actually? No, what is bond? Bond is nothing but the force of attraction. It is force of attraction, nothing. It is nothing but the force of
Who
attraction.
discovered
Simple.
that? Sir? And electrons
I
have bond each other. Like that, who discovered
I
this?
I told you that and Causal. They told Lewis and Causal.
Oh, okay.
Yeah. Okay. Now, can you tell me how many lone pair and bond pair will be there in case of that is C2H4, that is ethene? Can you draw the structure of
Yes, sir.
ethene molecule?
Yes, sir.
Okay, just try it out. Should get hydrogen,
Don't
the
tell
hydrogen
the
will
answer
only
in
complete
action.
duplet.
Tell him not tell the answer, sir.
Okay, I won't tell
Okay,
the
sir.
answer.
The thing is, he'll tell an answer so quick, it'll be wrong. He'll make 20 mistakes in that.
Even answer, you shut up there.
Yeah, that's an answer correct. And he'll do
You have to answer it though. You answer after first tell the answer.
last answer I only got.
You got one of the.
Guys,
You got
chill,
one of
chill.
the. That was also like guess.
You don't even get one
Hey, you
of
shut
them.
up. I gave you juice. Shut up.
So can you tell me carbon has how many valence?
Wait.
Yeah,
Oh,
so
sir,
I made the structure.
Okay.
No, I meant.
See, carbon has how many valence electron?
Yes,
Can you
sir.
tell me?
Sir,
Oh.
there's 0 lone pairs
Sir,
Exactly. Lone pair will be 0. Okay, very good.
and
Bond
bond
pair?
pair is 1, 2, 3, 4, 5, 6, sir.
six, sir.
Exactly 6. Correct.
Take the L, Nitish. Wow.
One question you answered and then.
Can you
Stop.
explain?
You didn't even
So
answer one.
carbon has
Wait,
actually
answer what is that?
Wrongly.
carbon is
Yes, sir.
actually forming here the double bond because it is ethene. That
Yes,
is alkene. That means there will
sir.
be double
Form
bond
single
and
bond.
single bond all other.
Sir, my
Will be
diagram is
just
completely.
like this. This is the diagram of C2H4, that is ethene.
Yes, sir, that's what I also drew. But I just drew the H directly above C.
I did the
Okay.
same thing.
So shall I move to the next page?
So
Yes, sir.
Yes, sir.
Tell me then what will be the shape of C2H2, that is ethine. C2H2, ethine. That means there will be carbon-carbon triple bond.
So I
Sir,
found out,
you just
sir.
given a hint, sir.
Wait.
I found out, sir. So
Oh yes,
Don't
very
tell
easy.
it, da.
hey, shut up,
Hey,
you
do
can't
it
tell me.
completely and then tell Ra. You'll make so many mistakes now.
Hey, I
Dude,
finished. What do you
Stop
mean,
that. Don't
da?
tell, da. Stop it.
Shut up, I'm telling that, sir. So
Yes,
there
even
is
I found, sir.
sir
I
already
won't tell.
did
I
it.
won't.
What is
I
this,
won't
sir?
I
tell.
have
Hey,
written
I'll
here.
keep quiet.
Nitish,
Yeah,
quiet.
Sir,
The lone pair
it's
will be
been so
zero.
long doing this,
So
sir.
I did. So what is it?
0
Like
and
it, like,
bond pair will be
so there's
5,
like
sir.
layer lone
5.
pair 0 and then there's like 6. No,
5.
5.
5. Da. Sir.
Hey, one small
So the-
typo from my mouth I made, and then you like, oh my god, you sucked at
Hey, mouth cannot make
I got
typo,
more.
da.
Okay, now can you
Metaphor,
tell me?
da. You don't understand what.
Yes,
Can you
sir.
tell me
We will
that
tell,
of
sir.
which
Yes, sir.
ammonia H2, NH3 ammonia NH3?
I don't know how much, sir.
I don't know what
I'll check the
sorry,
reading table.
I don't know what nitrogen has. I'm gonna look on my belt.
Just try it
Nitrogen
out, this one.
but it's,
I found it out.
Boron carbon.
No, I'm very slow at this.
Then we will study the properties
Hey, it
of
is, 3.
covalent
It is
compound.
2. It is 2 5. It is 2 5.
I thought
So
you
has
told the
anybody
answer.
has anybody
helping you,
completed?
So one sec.
Yes, sir.
Yes, sir. Yes, sir. Doing Yes, it, sir. sir. Yes, sir. Yes, sir. Done, sir. Run, sir. Run, sir. Run, sir. Sir,
Okay,
I
tell
didn't
me, tell
answer. Sir, it is
Linear pair is 2,
Hey, look
sir.
at this guy. Like, this is way worse than me. At least I answered.
Lone pair is how many and bond pair how many? Tell me.
lone pair. Sir,
Yes,
lone
linear
pair
pair
is
is 2,
none.
sir.
Bond pair is 3, sir.
Lone pair
Bond
is
pair
2.
3. Lone pair?
3. None, sir.
How
none.
many?
Lone pair
How
is
many
2,
lone
sir.
pair?
Wait.
2, right? No, sir. 2.
Nitrogen has 5 valence electron, right?
Yes, sir.
One.
Sir, one, sir. One
There's
lone
one, sir.
pair. One lone pair.
Oh yeah,
Exactly.
one lone pair. Oh yeah.
There
Oh
will
yeah.
be
Yeah.
one
Nitish,
lone
you're
pair,
slow.
correct?
You're so
Yeah,
slow.
got it,
You're so
okay,
slow.
okay.
Elbows.
One lone pair.
You're so slow.
It's not about this.
It's
It's about
fast,
who
but
gets
it's
the
not
most
correct.
marks. I got more than both of you in tests. Like
So lone pair will be only 1, right?
One mark less than you.
Okay, now let's
I
see the
got 12. You
properties
got
of
10.
covalent compounds. So
got
the first
11.
property is that
Yeah, I know you didn't.
they exist in all the 3 states.
10.5. Yes, sir.
They exist in all the 3 states. Got it?
Yes, sir.
They exist in all the 3 states. That is solid, liquid, and gaseous state, right?
Sir, so ionic compounds.
Ionic compounds, they were existing in the solid state, but covalent compounds can be solids, they can be also liquids, they can also be gases. For example,
So their natural form can be anything.
they can exist in all the 3 states. I will give you the example. For example, if I just talk of fluorine, F2 molecule, so in which state it exists? It exists in the gaseous state. F2 is a gas.
Sir, in
Now,
our book, all of these structures are given so weird, sir.
Yes.
It is
sir.
like on circles, sir.
okay,
So it's usually given.
you can make
It's like
on
on
your
big
notebook.
circle.
Yeah, you can make on your notebook neat and clean, not to worry. So
No.
then if it is Br2,
It's always easier to listen from someone than reading it ourselves. Sir.
yeah,
So
Br2
why
exists
do you
in
say
the
neat and clean, sir?
okay. If you like neat and clean, then you can make. If you don't,
It's easy to
then it is
understand.
as
It's like Sanka's face, sir.
What?
so I2 molecule, it exists in the solid. Iodine exists in the solid state, bromine in the liquid state, and fluorine in the gaseous state. You can give more examples, just water. Water exists in which state?
Liquid state.
Liquid state, right?
Liquid
Okay. Ammonia exists in which state?
Gaseous state.
Exactly, gaseous state. So you have to remember that these covalent compounds, they exist in all the 3 states. Now, can you tell me, are they good conductors of electricity or bad?
Good, because they form
Good.
They have
bad,
a covalent bond.
bad,
What do you
they're
mean?
bad.
They are good conductors.
Bad.
Covalent compounds are bad conductors of electricity.
Yeah.
Okay, we all took
Sir
a guess.
said it
Yeah.
like 2 minutes ago. Da.
We all
No,
took a
sir
guess,
said it 2
yeah.
minutes
That
ago.
is only if they are alone.
No,
like
sir
they-
said it now.
I know, but okay, yeah, right. Yeah.
Beyond
Oh, when they are
duplication.
Sir
alone,
said
like
it before.
when
When
they
I
have
asked a
individual
doubt, sir
ions,
explained.
they have charges.
Yes,
So
yes.
they
Okay,
are.
I will tell you again that when there is covalent bond, so that means electrons are not free to move. Electrons are not free to move. So when electrons are not free to move, how can it conduct
Don't
the
have a charge.
electricity?
Oh, yeah.
But there is exception. Can anybody tell me where is the exception?
Benzene.
In in gases.
No,
Sir,
it is the
HCl is
graphite.
a
Oh,
Graphite is a good
conductor.
conductor of electricity.
Only graphite, sir.
Oh yeah,
Yeah, it's the
graphite's an
only
exception in
graphite.
everything, sir.
Graphite is the
It's
yeah.
always an
In
exception.
science, there are
Stupid.
exceptions. So you have to remember this. So graphite actually contains the free electron, so that's why it can easily conduct electricity. But all other covalent
Can you tell me
compounds,
the chemical form of graphite, sir?
it's
Everyone
carbon.
just
graphite.
shut your mouth.
Okay, I will tell
It's
you
a
this.
allotropy of carbon, ra.
Yeah, it is one of the allotropic form of carbon.
Yes, sir. What did you say, sir?
I am just saying if you just wanna the structure of this graphite, I will make it on the next page. Have you completed this?
Yes, sir.
Sir,
Everyone
it
finish
is an
it.
allotropy of carbon, ra. There's
Yes,
like
sir.
no
Okay,
separate
Ra. I
graphite
mean,
Yes,
element.
I have
graphite
one
is the
question.
allotrop of
That's
What?
what
carbon.
sir.
Can you tell me what is allotrop?
So, I don't know.
Sir, four
Yes, sir. It is
combinations.
different structure but same elements. I'll tell it, sir. We wrote it.
Exactly, they
Sir,
have
Oh,
different
we
structure is
wrote this.
structure.
different
Yeah,
but
different
elements are same.
structure, but of
Exactly, they have same chemical formula but different structure.
Sir
Very good.
told this in one
Yes,
of
he
the
did. He
first
did.
class. I
Yeah,
wrote
I
it
thought
down.
that was isomers.
No, he told us in the
Wait.
second class.
I thought that was isomers.
First class.
Shall I move to the next page?
Yes,
Yes,
sir.
sir.
I thought that was
Yes.
isomers. Like same chemical
Okay, now
formula.
see here that graphite it is actually having the hexagonal ring structure, layered structure like this.
Oh, looks nice.
It looks more like a stretched out ring than a ring. Looks like a ring for Sankal's fingers.
Yeah, you have to make these hexagonal rings here.
More of a
So how
honeycomb.
long does it go, sir?
How much
Yes.
ever big your pencil is.
Like how long will it just continue like this?
That's a nice answer.
How big your pencil. It depends upon the size of your pencil.
Fun fact, not all pencils are made of graphite. The pencil you use is made of lead.
Yeah,
Some
pencils they
pencils are
contain graphite in it. Pencil contains the graphite.
Congratulations.
Not all.
So that means graphite is
Point
used
pencils.
for writing purpose. It
Most
it
graphite
marks the
also.
black, right?
Did you know my
So,
pen
like
was
how
made
much
out
is
of
one
graphite?
atom or molecule? How big is one molecule of graphite, sir?
Bigger than your
What is that question?
No, like one molecule of graphite alone, how do you represent
Sounds
it in
so
structure?
stupid.
P is equal to 1.6 near
That doesn't sound
420
stupid.
into
You're just dumb enough to you're not smart enough to understand it.
What do you like? What do you mean by what's the size
It's
of
good
a
knowing
car?
extra language, but it's not good not
Not
doing
size,
basic
I
See,
didn't
stuff.
even use the word size.
Okay, everyone shut up. Everyone shut up. Just
so
continue.
see, actually here you cannot
just
say
use
that
it,
one I am having one molecule of graphite. Graphite and diamond they are just the allotropic forms. You can say one molecule of carbon because carbon is the element here. But when you are just talking of graphite, you can just express it in grams. If you are just having, let's say you are having 1 mole of graphite. 1 mole means Avogadro number.
Like at
That's
one
six.
point, no, how will it?
You cannot say one molecule of graphite. What is that? One molecule of graphite. You can say one molecule of carbon.
One molecule
Okay,
of
sir.
graphite.
Just
One
you are
molecule of
having
I have
diamond.
a doubt, sir.
okay.
Sir, it's not it's related to the previous class.
Yo.
Sir, so you remember that I remember you saying that the shells extend up to letter Z, right, sir?
Yeah.
Sir, what comes after Z, sir?
Finally. Your favorite.
See, actually, whenever we talk of shells, there is K, L, M, N, O, right?
Yes,
Yes,
sir.
sir.
Etc. Okay, okay. Tell me
Till
how many
Z.
electrons
Two.
can you tell me
Two.
how many electrons can be accommodated in
Two.
K? Okay,
2,
then
8,
8,
18.
18, 32. And then
32,
after the 32, what is 30? After
then
30?
Oh,
25. Okay. So, 50.
64. No,
50.
no.
Exactly. Now, can you just count how many electrons we have accommodated up to O?
28,
50
and
plus
then
30 is
40.
72. 72 plus 18 is equal to 90. 90 plus 100, sir.
Okay, if it is 100,
100.
then we are having P. We are only having these because only we are having 118 elements. So in total, we are having 118 electrons. So how is the talk of after Z? It's only up to P. I am just saying that if we are having more electrons, we can write O P then Q R S. Uh, it cannot reach up to the Z. It cannot reach there.
So
Got
we
it?
are far behind
Only if you
control
discover an
person.
element.
Yeah, exactly. Because there are only 118 elements yet discovered. The properties of these elements we actually know.
Ahead in the future.
And none
Okay,
of them have more than 118 electrons.
exactly. Okay, so
We
now
didn't discover that.
can you tell me the next property of these covalent compounds? Will they be soluble in water or insoluble?
Insoluble.
Exactly, they will be insoluble in water because they are not polar, they are non-polar, right?
Yes, sir.
Yes, sir.
Insoluble in
Sir,
water.
but
Unless they're
they're
free ion.
soluble.
After they
But they're
become
soluble
free,
in
after they,
non-polar solvents, right?
Exactly, but soluble in non-polar solvents. Very good.
but they are only they can't they're insoluble in water only because they are not free, right, sir? Like not free
They
ion.
are not polar, yeah, because they are not polar, so they cannot be soluble in
Don't
water.
have a
Because
charge.
actually that is soluble, which is polar in nature. If any compound is polar, that can be soluble in water. So can you tell me what type of reactions they show? They show molecular reactions. They undergo molecular reactions, right?
So what is molecular reaction, sir?
Molecular reaction means those reactions in which molecules take part.
It's like
I will
redox
give you the
reaction.
example. I will give you the example. And molecular reactions, they are slower than the ionic reactions. For example, if you just talk of, let's say you are having methane molecule, CH4, it reacts with oxygen molecule. So it forms carbon dioxide and water. So this is your molecular reaction. This is not the ionic reaction. Got it?
Sir.
Yes, sir.
Okay, then can you
Yes,
tell
sir.
me what will be their melting and boiling point? Will it be low or high?
I think low, sir.
Exactly, low melting
Sir,
point and boiling
actually, the
point.
next class
Random
started,
test.
sir.
Exactly, we have also completed our class and we have also completed this chapter also, that is the atomic structure and chemical bonding. I hope that you will keep revising each and everything whatever I have taught and you will be ready for the exam, right?
Yes,
The
sir.
exam or what exams? Oh,
Test.
yes,
Okay,
sir.
have a nice day ahead. Any
Thank you,
doubt,
Yes,
any
sir.
sir.
question?
No,
No,
sir.
sir.
Most
No,
welcome.
sir.
Okay, most welcome.
Bye bye,
Bye.
sir.
Nice, sir.